All right, and welcome back. So, what we're going to be doing next is we're going to learn the second rule, the 45, 45, 90 right triangle, yet another very special triangle with its own specific rule. So, you should have already checked your answers for the problems you did earlier. Now, for a 45, 45, 90, there's no such thing as small, medium, large. We're going to save those letters SML for a 30, 60, 90. So, here we have a 45, 45, 90. And if you look, we have this angle right here, it's 45. We have this angle right here that's also 45. But that brings something from our past up here, and that's the fact that when you're working with a triangle and two of the angles are equal to each other, then we know that two of the sides should be equal to each other. And in this case, the two sides that would be equal to each other are the legs. That's why if you notice, in the last one we did, we had a short leg and a long leg, a small and a medium. Well, that's not the case here. Because these two angles are equal to each other, then that means this leg is equal to this leg. So they're actually equal to each other. So the legs are congruent, as we would say in geometry. That's why there's no distinction between small and medium, because there's no such thing this time. But that means my work is actually going to get a lot easier. And based on Pythagorean theorem, which is how they came up with the rule here for the hypotenuse, we get to use this concept, and we're going to call it leg hypotenuse. And so last time it was small, medium, large. Well, this one is LLH. So we're going to have our own little letters for this one, just so that we can tell the rules apart. But here are the rules that we're going to be using. It's K, just like last time, but it's K again because remember, they're equal to each other. And my hypotenuse, which is just slightly bigger, will be that same K, that same scale factor with the radical 2 being multiplied next to it. And so here we go. This is one of the easier parts that we do. And so in this case, yes, here's a 45. Yes, there's a 90. Then this is a 45, 45, 90, which means here's my hypotenuse. And remember, there's no small, medium, large. It's my hypotenuse, leg. So LLH is what we're going to be doing. And so here comes that LLH again. So LLH. My rule for LLH is K radical 2. And if you're wondering where I got this, it's right here. It's never going to change for a 45, 45. Again, it only works for that type. So now we're going to do what I did earlier and ask, okay, what side did they give me? What's the only number I see? These are not numbers, and no, we're not talking angles. This is the only side they gave me, a 5. And notice it's attached to the L. So here's an L. I'll put a 5 right there. So that's where I put my K. And look, anywhere I see a K, I know that I should be using, as soon as I see that K, I see a K here, well, then I use the same number 5. Hey, I see a K right there. Well, then I'll use the same number 5, but because it's the hypotenuse, with the radical 2. And now all I have to do is go back into my picture and put these where they belong. The other leg is 5. Look at that. You just found Y. The hypotenuse is 5 radical 2. You just found the X. So again, based on this formula, our concern is to find this. I don't bring the X and the Y into the mix, right? Our concern is to work with that scale factor. So when I look at number 2, well, for number 2, yes, I see a 45. I see a 90. This is a 45, 45, 90. So here we go again. This is the 90, so leg, hype. And when I do leg, hype, leg, hypotenuse, then I use my rule here. And my rule says K radical 2. And now I'm ready to go. The only side they gave me was this. This is the only number for one of my sides. The others are letters, so I can't use those. And it's written with the H. Then I'm going to write it here. 10 radical 2. And just like that, I already see it. Check this out. My K is 10. right? K is whatever's next to the radical 2. So then it has to be the 10, which now means here's a K, I put a 10. Here's a K, I put a 10. And just like that, we have our two missing sides, 10 and 10. The 45-45 always tends to be the easier one, of course, because like I said, the two sides are equal. The two angles are equal to each other. So I'll put a 45 in there. And that's why we label leg, hypotenuse, so that when I bring in my formula, the leg height, my rule is always the same. And that rule is K radical 2. This is what we use to help us do our problems. In fact, look, let me do one of these down here from the examples that you're supposed to kind of work out on your own, but we'll do some of these together. So I'm gonna do this one. Now, if you notice, you might say, yeah, but there's no numbers. There's no 45 or anything. Remember what we mentioned earlier. If they show you that two angles are equal to each other and there's a 90, then that means the only angle that can go here is that 45. So there's that 45. Well, then I'm ready. They said, find the missing sides. All right. Then I'm going to call it leg, height. And here we go. Leg, height. And though, let me bring my formula in. I almost forgot. K radical 2. And the only number that I see is this one. And it's written under the letter H or with the letter H. So I'll write it under the letter H. 15 radical 2. And I already see it. I don't know about you, but I already see it. Look at that. My K is that 15. And if I know what K is, then I bring it in. There's a 15. There's a 15. And I have officially found the two missing sides of this right triangle, this very special right triangle. So right now we're going to pause the video so that you can try these three out. Careful with this one. Now notice this one does have X and X, so the sides are equal, which means leg height is available for this one. Okay? So we're going to pause the video for you to give this a try and then double check your answers. So now that you've had a moment to work on those problems, we're going to finish our notes for the day with some advanced special right triangles. Now, what they're saying here is, look, if you have a rectangle, so here I have a rectangle. No, the sides of a rectangle are not equal to each other. Opposites are, right? Like these are equal to each other. These are equal to each other, but they have different sizes. But here's how it connects to what we're learning today. A diagonal divides a rectangle into two congruent triangles. So when that happens, because they're not equal to each other, and I don't know what the angles are, we are allowed to use the Pythagorean theorem, which means I'm able to use this rule whenever I see a rectangle or a concept like that. Could also possibly work for squares as well, but that's when we can bring in the Pythagorean theorem. On the other hand, when I have a square, now a square is a little more special. Yes, there's 90s. But in this case, look at this. All the sides are equal to each other. So here we were looking at this triangle. That's what I'm telling you. You can use the Pythagorean theorem here. Look at that. A, your B, your C. In a square, I can also cut it into two triangles that are equal to each other. But if you notice, there's already something special in that pink triangle. Yes, I have two congruent triangles. But these two sides are equal. And if in this pink triangle, learn to ignore that bottom one, if the two sides are equal, then guess what? This is now a 45, which means I can use the 45, 45, 90 rule. So I can go into this picture and start going leg height so that I can find that maybe this line in the middle, maybe that's what they wanted. And finally, we have this concept known as the equilateral triangle. And when you're working with an equilateral triangle, well, look at the picture already. It says these sides, actually all three sides are equal to each other, but that doesn't help me. What does help me is that because it's equilateral, every angle is equal to 60. And because this one was cut right down the middle, that one was equal to 30. And look, surprise, surprise, we now have, once again, a 30, 60, 90 triangle. That means those rules of a 30, 60, 90 can apply to half of this picture, right? Because yes, I'm going to have two congruent triangles, but I get to use the 30, 60, but only if they say the words equilateral triangle. So there's my small, medium, large. Again, you're concentrating on the one that has that color, that orange color in this case. So let me show you how we can use these rules here, okay? So we're gonna make this a little smaller there so that we can still see the rules. Okay, so in question number 1, it says, Yelp is a square. All right, look who's available in a square just in case we need it. 45, 45, 90 is available. So they said this is a square, so you know what? I'm gonna put this right here. I know these are 45s then, just in case, because I know this rule is available. But let's keep reading. Yelp is a square and its diagonal, so that's this line, has a length of 8 radical 2. And then they said, find the length of one of the sides. So they want me to find the sides out here. Well, we know all the sides are equal. But you see, here's where our rule just kicked in right now. We said, yes, this is 90 and these are 45s. So check it out. Here's what we can actually do with this problem. I'm just going to look at this picture right here. Not the entire thing, just that little triangle. And look at what we have here. A 45, 45, a 45, 45, 90, which means leg, height. LLH, just like we did earlier. So here comes our rule for the LLH. K radical 2. And look at the only one they gave me. The only value that they gave me in this problem was the H. So I'll write that right here. 8 radical 2. And just like that, I think you see it, or I hope you see it. My K is just the 8, which means I see a K, I put an 8. I see a K, I put an 8. And just like that, they said, find the length of one of the sides. We have right there. It was an 8. Now I could write it for all of them, but they only wanted one of them. You could write it in here too if you want. But that's what they were asking. Again, that's why when you see a square, a 45, 45 becomes available. Now, I'm not sure what happened here, but they said this is an equilateral triangle. Well, here's the catch. If this is an equilateral triangle, they said, find the length of the altitude. Okay. Now, remember, if it's equilateral, all of these are 10. All of them are 10. But if they want the altitude, they're asking me to find this line right here. They want to know how tall this triangle is. Think of it that way. But they want that number right there. That's what they're looking for. But remember, when it's an equilateral, I can officially say, all right, this is 90. There's my 60. This is the small, medium, large concept. So we're going to go with the small, medium, large here. And I'm only going to look at this picture. And no, be careful, I can't use this 10. The 10 is the whole thing, so I'm just going to cross it out, get it out of the way. I'm going to use this 10 out here. So here we go. Small, medium, large. All right. Small. Medium is what I'm looking for. Large. S, M, L, K, K radical 3, and 2K. And if you notice, the only number that I was given was that large. So I'll make them equal to each other. So 2K is equal to 10. Divide by 2, and K is officially 5. So everywhere I see a K, well, I'm going to put a 5 in its place. So I see a K, I'm going to bring in the 5. 5 radical 3. I see a K, I'm going to put a 5. So I officially have every side I want. So this side right here, we now know is officially 5. But that's not the one they were asking me. Remember, they were asking me for this purple one here. Then there's my 5 radical 3. We have officially found the height that we're looking for. So again, this is how we can use these concepts to help us out. And finally, last question of the week here. It says, find the perimeter of a rectangle. Well, first of all, perimeter means they want me to add up all of these, not the diagonal. They're trying to build a fence around this rectangle here. Well, I already know one of my numbers is 8, so that's good. But perimeter has 4 sides, so it's 8 plus blank plus blank plus blank, because technically I'm still missing 3 sides. But if you know your rules about rectangles, if this is an 8, we know the bottom one is also an 8. So I get to write the 8 twice. So if you notice, I'm really just looking for this side right here. That's what I'm missing. But this is why the note said, when you have a rectangle, let's look at it, one little triangle right here. Yes, it's a rectangle, so this is 90. It says Pythagorean is available. Nah, there's no 30-60 here. None of that, because we don't have angles. But I can use Pythagorean, something squared plus something squared equals something squared. And my longest side of this pink triangle is the 10. That's the one that goes by itself. The legs are the x and the 8, x and 8. So here we go. X to the power of 2. 8 times 8 is 64. 10 times 10 is 100. And when I subtract that 64, we get x squared is equal to 36. And just like before, the only thing in this world that gets rid of a power of 2 is a square root on both sides, of course. So x is equal to 6. Now remember, you can't be happy and go, there, I found my answer. You haven't really answered the question. They said, what's the perimeter? I want to build a fence. Well, this side is 8, this side is 8, this side is 6. Well, so is this one. See, now I can actually add everything up. And when I add it up, we see that the perimeter is actually 28, and that's my answer. So with that said, don't forget, you're working on the next page. You're working on the classwork. Have a wonderful day, everybody. And don't forget, you have an assignment on Big Ideas Math.